Welcome to the SMC Journal podcast and welcome to 2024. This is the podcast that's all about software and systems engineering, networking, infrastructure, testing, tuning, observability, AI, and security, much more. I can't remember all the stuff that we do, but I am Scott Moore, your host, and I really appreciate you being with me today. We have an awesome show for you and some nuggets of wisdom that you are definitely going to want to hear, whether you are into cloud computing, whether you are a systems engineer, or whether you're just a consultant. You need to listen to the words of our guest today. His name is David Linthicum, and if you do not know who he is one of the chief cloud architects at Deloitte. He's also an internationally known speaker and wisdom sharer of all things cloud related and more. So he is our guest today, and I'm going to let him talk more about himself. But I've been wanting to have this interview with him for some time, and I'm so excited that you're going to get a chance to check it out. Before we get to that, though, let's talk about the sponsors that make this show possible for you to watch.
This podcast is sponsored by Bryte Payment Solutions. They provide merchant services for a wide variety of credit card companies. They take most major credit cards at the lowest rates and fees possible, and they can help your business generate higher revenue through a variety of payment solutions they have, including their own point of sale equipment and custom software. If you take credit cards for your business, you should contact them and see how they can help you. Go to brighteps.com and tell them Scott Moore from the SMC Journal sent you.
So, one thing that really bothers me a lot is the fact that I feel performance engineering has sort of taken a backseat role when it shouldn't have. I think, of course, I'm biased, but I think performance engineers need to be the rock stars that the C-level always want to be around because we want the same things that they want. And I think 2024 is the year of the performance engineer for multiple reasons. And if I have to try to spearhead that myself, I'm going to do it. But I never really get a chance to talk to somebody that is at that executive level as often as I would like. And when I get a chance to talk to them, I always have to ask them about how do we get performance to become take a more important role in things like lifting and shifting the cloud from on-premise to the cloud, your digital transformation. How do we get to be at the head of the line above some of the other things because we make such a difference to the outcome of that by the things that we provide, optimization-wise, service-wise. And this is where my guest, David Linthicum, can help me understand that and you as well. So without further ado, here's my guest, David Linthicum. Hello, David. Welcome to the SMC Journal podcast. It's great to have you.
It's great to be here, Scott. Thanks for having me.
I promise I will try to not act like a fanboy throughout this interview and giggle too much, but I have really wanted you to be on this show for a while, so thank you. Could you introduce yourself to our audience and explain a little bit about what you do and the kinds of information that you share on the internet?
Yeah, I'm an architect by trade. Been focused on cloud computing actually for the last 20 years, and really a cloud SME, author, speaker. I always call myself a B-list geek. I'm usually the second call that someone makes for a keynote, not the first. And basically focus on excellence in architecture, cloud optimization. I do a lot of writing and speaking, including the book I just published behind me, Cloud Computer Insider. Got a YouTube channel that I just launched last week. I guess have the same bucket list as you. Get some content out there. Do a lot of LinkedIn posting. I'm in the InfoWorld blogger, as well as have a podcast. So lots of influencer kind of stuff is probably the best way to describe me. But I focus on the realities of what it takes to implement cloud-based and really enterprise-based systems and making them work and being very pragmatic in the advice and things like that.
Well, I found out about you a little over 2 years ago, and then I saw that you're a fellow Deloitte alumni, and I started looking at what you were posting about, especially when it came to the super cloud, hybrid cloud, and about repatriation from the cloud. It's a very interesting topic, and I've actually been talking a lot about that on my Performance Tour live events. And as I begin to go through some of the stuff that I reference from you, the eyeballs get bigger and bigger from especially the system engineers, the architects in the room, and they're like, we didn't think about some of this stuff. We probably should. So I want to talk first about how I found out about you when I heard the term super cloud. And after I started reading about what that was, and I'll let you talk about what that is, I immediately went to KubeCon 2022 in Detroit, and went to all the major vendors there, VMware and Amazon, some other people. Nobody could tell me what SuperCloud was. They looked at me and they said, "I don't know what you're talking about." So I was maybe a little bit ahead of my time there. But could you talk a little bit about what that is, and are we any closer to seeing that now?
Yeah, basically, it's a silly name for a very important architectural concept. And the idea is that if we're leveraging multiple clouds and also the enterprise systems and edge-based systems, things like that, it doesn't make sense to manage them all as silos. So it makes sense to put an abstraction layer of cross cloud, cross technology platforms, operations, FinOps, security, where we're able to, in essence, create a platform that's able to stretch across heterogeneous sets of clouds. Whether you're, doing a four public cloud multi-cloud with your enterprise systems, your legacy stuff. The idea is let's stop solving these as tactical instances of the problem, making things more complex. Let's solve it a single time by building a layer of technology on top of everything. And that's really what a super cloud is. It's a concept. It's really conceptually, it's been around for a long time. We've always had the notion of leveraging cross technology abstraction. We just didn't have the technology and the wherewithal to make it happen. But what the stack looks like is there's a security layer in there that does security management, operations layer, typically AOps tools that are in there, FinOps that goes across the cloud, performance engineering, DevOps, all these sorts of things where we're trying to find commonalities between these platforms versus picking up whatever native tool is cool for the clouds that are involved. And the reason we got to it is because people were spending way too much on the complexity of all these things. They couldn't keep the talent around they needed to make it happen. Actually, complexity is the enemy of security. So that became a problem. So they hit the budget wall in many instances. They said, okay, what are we going to do? We need to do something smarter rather than harder. We can certainly start adding additional clouds and adding additional services on to support the innovation within the company. But probably a better take of this is let's create some sort of a common framework. And that's kind of the idea between super cloud, meta cloud, whatever you want to call it. But it's abstraction, it's commonality, it's cross-cloud services, it's a centralized control plane. Concept's been around for a long time.
But I've heard you say on other podcasts, even if the largest of the largest cloud vendors wanted to have every single client in the world, they don't have the ability to support that. So they're going to have to work together to make this a possibility. Are you seeing that happen now?
Yeah, they have to. If you notice some of the now the cloud providers are talking about multi-cloud optimization across clouds, things like that. So they know they have to work and play well with an ecosystem where they're not going to be the only player. Kind of their push for the last 10 years has been run everything on our cloud, migrate as quickly as you can, get all your data, get all your applications on our cloud. We'll support you. We'll make it cheaper, better, faster. And then people realize that it's not cheaper in many instances. It's creating a complexity problem, and we need to leverage the best of breed services to support our applications. And sometimes that's going to be on Amazon, Microsoft. Sometimes it's going to be on Google, Oracle, or even on premise. And so we're getting to this ubiquitous architecture where people are leveraging whatever platforms they need to leverage to get the best advantage that they can, leverage the best of breed technologies. And I think they realize that now. But it used to be, kind of funny. My story was every time I spoke at a cloud conference, they would go through my presentation, remove everything that said multi-cloud, because that wasn't the message they want to promote. And I think right now everybody's going to have to work and play well together. They understand they're going to be a component. They're not going to be a replacement, which I think is a much more healthier way. And by the way, their business will grow like crazy when they do that, because people are able to leverage their technology in a much more successful state, and they're able to leverage their technology for the best of breed solutions where they can gain the most value. So, optimization and overspending in cloud computing has mainly become people just focus on a single cloud provider, doing everything in the native capabilities. They locked into that provider, and it wasn't able to provide them the value they thought they needed.
Exactly. And you mentioned expense, which brings me to my next point, which is as we've done these lift and shifts and COVID kind of pushed that into high gear, we saw the oh boy moment of those cloud bills when the lift and shift didn't have an optimization component to it. When they did it, in my opinion, that was a huge mistake. And then we suddenly hear about a new ops. We hear about FinOps, and the FinOps Foundation comes, which is really just code word for stop spending so much money, and let's figure out how to stop doing that. But I think of this, I mean, you even mentioned in your latest blog why most companies suck at digital transformation. the fact that there's $3.4 trillion going to be spent by 2026. And that sounds like a lot of wasted money to me if they're not going to do the optimization when they move. How big of a problem do you think that is? And when I'm talking about optimization, I'm talking about performance optimizations at the same time, and infrastructure, software components, all of that. How much do you think is wasted money?
Huge waste of money. I think people in many instances are spending, in some instances, 10 times the amount of money they need to spend to deploy the same system as they can on an optimized platform. And that's because they made wrong decisions. They picked the wrong technology, used the wrong approaches. And to your point, they just picked up very poorly designed systems that were running on premise and put them on the cloud. And now they had a poorly designed system running in the cloud. And so it was under optimized. It was leveraging too many CPU cycles, too much storage. They're replicating data all over the place. They don't have a single source of truth, that kind of stuff. So you look at what the optimized state needs to be, their ability to get to something that's completely 100% optimized. You're never going to be 100%, but you're trying to get as close as you can. They're way off.
Mhm.
In many instances, they're 10 to 20% optimized. They're wasting. So all that money, the 80%, is going to be wasted on just running stuff that's leveraging unneeded resources and are that resources you don't have to leverage, and that's costing them money, and it also has an impact on sustainability and consuming too much power. And I just see it as a huge waste right now. So it is a fact of the matter is that when we're dealing with cloud, it's heavily convenient. So I'm able to allocate resources pretty much at the speed that I need to. And that power is just kind of gone to the heads of people who leverage it, so they can just leverage as many resources as they think they need. Normally, it's too much headroom. They're leveraging too much stuff. They're not deallocating once they allocate it, and they're not leveraging those resources effectively. They're running highly inefficient applications on them that are in desperate need of doing a refactor to optimize them for the particular systems, even optimize them to consume less power. So it's kind of funny. It's like you drive up to a corporate headquarters and they'll have electric car parking and they'll have solar panels on the roof and all that kind of stuff and talk about ESG and sustainability. And then you look at their existing infrastructure, they're absolutely wasting 10 times the amount of money that they need and consuming 10 times as much power as they need to do the same thing in a more optimized state. The problem is that you have decades of technical debt that people aren't willing to go back in and make the changes on. So they just kick the can down the road. And so they move under optimized technology to different platforms, kind of hope for a miracle to occur. Last one was cloud. And I think many instances people were we're thinking that cloud computing is going to provide the performance advantages and the resource advantages and make things cheaper, better, faster. And it didn't do that. As I write about in my book, I think people are spending about 2.5 times what they thought they would be spending on cloud. In 2022, we found that in the survey. So what they did with FinOps is they said, okay, game over. We're going to have to put some discipline behind this. And even though we had cost governance in cloud computing for a long period of time, it's putting a formal methodology and process and program in place where we're able to keep track of what we're burning and spending to see how bad we're doing, but also the ability to kind of move toward an optimized state. In other words, we have a good understanding of what the application is doing wrong and the amount that the optimized system is costing us, and then we have a way or a method to measure success in moving forward to optimize those systems. So many instances, the systems are getting optimized, they're getting changed, they're getting streamlined, they're re-engineering them for performance, all these sorts of things because FinOps is around, because it's putting up in front of them, you're wasting a lot of money. And by the way, based on what we see in the AI stuff is great on this stuff now. We've done a survey with your peer companies and look at the best of breed technology. Best we can figure, you're wasting 80% of the resources that you don't need to leverage. And so, if you move to a more optimized state, that's going to provide you with money that goes right to the bottom line. The big thing is too also money that you can reallocate to other resources, building innovative systems, taking your business to the next level. And in many instances, we're just firefighting. They're just trying to keep systems running and not necessarily looking on how to make them run better.
I hope that the software engineers and the performance engineers of the world are listening to this. And as you talk they should be hearing dollar signs of savings. It's low hanging fruit out there that we can go get. It's out there for the taking. It presents a big business opportunity for those companies who focus on performance and making those changes. And from a FinOps perspective, I see the performance engineer as the best friend of FinOps because we want the same thing. We want to make it more efficient, not just faster, but we want to make it a CPU consume less resources and be more sustainable. That's just what we're all about. Hopefully we can make that more important going forward. What about 2024? We're right in January as we make this recording. Is AI the savior to all of this, or what do you see around the bend for this year, or what's coming that we should know about?
Yeah, I think AI is another problem to solve because we can get into a whole new optimization struggle, as we try to make these things run on leaner platforms to basically make sure that they're minimizing use of CPUs and things like that. So the AI systems are going to be expensive. They use a tremendous amount of storage for the training data. LLMs are huge, typically, and you're normally mixing and matching these things. And they also run on processors that many people don't have right now, GPUs and TPUs. And so huge expense coming down the line as I'm, really kind of, doing metrics around building some of these giant generative AI systems that my clients are asking me to build. And I don't know, I'm not sure how we're going to get there without a tremendous amount of innovative engineering to make sure we're minimizing utilization of resources. Because right now, people want to build, 10 generative AI systems for different business purposes. You can afford to, based on the amount of resources it's going to leverage. And even if you're doing a build versus buy, you're building it on premise, you're just consuming the resources in a different way. And if you're consuming them in an under optimized state, that's really no different. And so 2024 is going to be realization of that. I think that there's not a lot of generative AI going on right now, by the way. So everybody's talking about it. It's basically cloud computing conferences have become generative AI conferences.
Mhm.
And people are sizing this stuff up. And that's normally why my phone rings, doing the architect thing. And they're trying to figure out how to build and what to build and the right use cases to build. So 2024 is going to be a tremendous amount of planning that occurs around building and in digital transformation to generative AI. And I think that that needs to occur first. It's kind of healthy because we're kind of at a point they realize they can't afford everything that they need to make it happen. And then to that point, and to the discussion we just had, and not beating a dead horse, but optimization is going to become front and foremost. So if you notice that the cloud computing conferences this year, including reInvent, they talked about optimization, which was kind of verboten in the past conferences because they realized that their clients are complaining in the fact that they're not getting their money's worth out of the system. In many instances, it's self-inflicted wounds because they have highly inefficient systems. So it's really tough to blame the cloud providers because all they're doing is providing CPUs and storage as services. And if we're using them inefficiently, then that's kind of on us. But so they're struggling to kind of take things to the next level. We're at about a 30 to 40% migrated tasks, workloads migrated to the cloud at this particular time. And I think it's stalling a bit because people have run out of the low hanging fruit. They realize it's much more expensive than they thought it was. So they have to kind of get by that. They understand that the generative AI system is going to be important, but now it's like, where are we going to run it, and how are we going to afford to make it run? So it's getting down to brass tacks in terms of that stuff. It's one thing to talk about 2024. We're going to make tremendous impact and inroads into generative AI. I think absolutely that's going to be the case. That's going to happen in an automatic state based on the market. The real work is going to occur in the back end, in doing the engineering and doing the architecture to make sure we can run these things at scale and it doesn't break the bank. And that's kind of a boring, buzzkill thing, but I think that's just the reality of it.
Well, not to me. As I hear you talk, I'm thinking of all of the synapses are firing off on. We need to do performance engineering on the LLMs, on the generative AI, so we can get more bang for the buck out of it right now. So, and that's really This really gets to this surprise question that I have for you, because everything you say points me that I'm in the right place. This should be the year of performance engineering. If we want efficiency and reliability and sustainability that everybody wants, we're the people to give that to the executive levels, if that's what's keeping them up at night. My biggest question, because I know you deal at the executive level a lot, I deal more with the technical managers and the engineers, the people out in the field doing this, but I don't necessarily think like the C level. And I want to know, how do we get performance to the big boys table? How do we get that conversation to let them know we're the rock stars you've been looking for? We're the people you want to take selfies with, because we want lower risk, higher performance. All of these low cost, all these things they want, we want to give that to them. How do we become those important players?
Yeah, you have to address the pain that they're feeling. If you're trying to get a board level or a C level discussion, it's the fact of the matter is that we just did an audit and we looked at the performance capabilities that you could have and the optimization capabilities that you could have. And here's your bill. And if you're willing to pay that money moving forward, it's going to be money you might as well put in the middle of the table and set on fire. And so, as an efficient business and someone who's really going to be beholden to their shareholders, which is why business exists, then we need to start moving in this direction. And so then it's going to be how we do it. You're probably not going to have a discussion with them in terms of how you're going to optimize Kubernetes and container-based infrastructure, but you are going to have the discussion in terms of metrics to measure success. In other words, what you're going to do in terms of an engineering term, which is going to generate more money on the bottom line. And that's cut and dry what they want to hear. And so that's the way you have the discussion. Of course, that takes place to the lower level. You're normally dealing with the tactical operational people in terms of how you're doing the re-engineering performance stuff. And also it becomes down to the architects that are there, the CTOs and the chief architects and the CISOs, in understanding the problem and understanding what macro things have to be changed before we change the micro things. You got to remember there's two layers here. Number one, inefficiency in the architecture. We just do not have a configuration of technology that's getting us anywhere close to 100% efficiency or something near efficiency. And the tactics underneath there in terms of swapping out the technology and reinventing, refactoring existing applications, performance enhancing databases, removing some redundant data out of the loops, all these sorts of things that really need to occur on the bottom end, which are fairly easy to occur once everybody knows what the problem is. But it is getting the people on board who are designing and maintaining the systems that are going to kind of take things that are going to take things and make things work. And so those are, you have to get on. So in other words, get them on board. So in other words, the C-level and the board level, they realize there's an issue. Don't care how you solve it. They're just looking for it to be solved. Some money can be generated. In this case, savings. And then the CIOs and the CTOs and the chief architects stuff have to really kind of understand and take the initiative that they're going to put a plan in place to systemically change the problem and what that needs to look like from a macros perspective. And maybe it's the top, 20 applications that are providing the least amount of optimization, they're causing the most pain, that need to be set up and the ways and approaches to make it happen. And then once that happens, it's like I said, it's fairly easy on the back end to do the engineering you need to do to get to a much better state. In some instances, a lot easier than people think. I've had systems that were completely inefficient that were migrated to the cloud. And we've had developers spend a couple of 3 days on just doing some performance tweaks on these particular systems, and they were able to gain 50% efficiency. In other words, they cost 50% less money than they did before. And people were they didn't understand it was that little a time that needed to go in to fix some of these issues. And you got to make the time, you got to have the budget, you got to put optimization, cost appreciation, performance management, performance engineering into every stage of the game. And this has to come from the top, from the stakeholders. You're not going to sell a software engineer on doing this. They understand they need to do that, but they're going to do what they're told. You need to sell the leaders in the company that they're going to move in this particular direction. They're going to spend money on it. It's something that's going to be a priority.
Interesting. David, I think I could listen to you all day. You shared some really important things that I think our performance community really needs to know. How can people find out more about you or get a hold of your book, or so that they can read up on some of the stuff you've been talking about?
Yeah, well, the book's on Amazon's Insider's Guide to Cloud Computing. You can reach me on LinkedIn. That's probably where most people find. That's how I think you and I connected.
Mm-hmm.
I respond to most messages. So reach out and tell me what you're up to and things like that. I'd love to hear what everybody's doing out there, and also read my blog on InfoWorld, listen to my podcast, and listen to my new YouTube channel, or watch my
Awesome.
new YouTube
I'll
channel.
make sure I bring that up on the show when we share this out there. But thanks so much for being on the show today, David. It's been great.
It's great, Scott. Thank you for having me.
All right. So, okay, bucket list item achieved. Screw the Hawaiian vacation. I've had David Linthicum on my show. I'm really, really happy. And this is the website for his blog on InfoWorld. As we recorded this, his latest one is Why Most Companies Suck at Digital Transformation. He's always putting out weekly content, weekly blogs, and you can follow him on LinkedIn like I did, and so do about 179,000 other people. So what he says is very important. So thanks again for being on my show, David. I'm on LinkedIn quite a bit myself, but you can find me on a lot of different platforms. And if you scan that QR code, it'll take you to all the ways that you can contact me. And of course, you can always send me a wonderful email at heyscott@smcjournal.com. I would love to hear from you. It would be great also if you would be willing to subscribe to my YouTube channel so that we can grow this channel and make sure that more people understand the importance of performance engineering in our society today. So, with that, I thank you again for watching. We'll see you on the next SMC Journal podcast. I'm Scott Moore.